Alright, let's discuss insert sort. What is an insert sort? Basically, it inserts a single element in a sorted list for a given iteration. Say we have elements like 3, 2, and 1. So our goal is to come up with a sorted set. Say we want to come up with 1, 2, and 3. So insert sort manipulates the given set by usually considering the first element to be already sorted. Say you have 3 being sorted, and we are looking at the unsorted elements. The unsorted elements in this case will be 2 and 1. So we will first choose 2 being our unsorted element. Say we'll choose 2 and compare it to 3. So if 3 is larger, then we need to swap the 2 values, or somehow you need to insert 2 prior to 3. So it will be, the sorted set will become 2 and 3. So 2, 3 after comparison. So after that, when you're going to choose the next value, which is 1, next unsorted value, so in this next iteration we will focus on 1 as our key value, and first we're going to compare that with 3. Since 3 is larger, then we are going to swap the 2 values. So we will have an intermediary 2, 1, and 3. And afterwards, we're going to perform another comparison. Since 1 will be greater than 2, then we need to swap once again until finally we will get the result to be 1, 2, 3. So after the swapping of 1 and 2, we'll get 1, 2, and 3. So this is just a simplification, a simple example, but I hope we can see already the steps to be followed. So first off, we need, let's just come up with a name for this. So insert sort, and accepting an input of an array of elements. So for the input, we're considering a sequence, say a sub 1 up to a sub n, where these are, say, integers or could be real numbers. And for our output, the output is just a permutation, so we could consider it as a prime. So you have a1's prime up to an prime, where a1 prime is the smallest, A2, and so on. So if you notice, like, the way we solve 3-2-1 is we merely focused on the second element up to the last, because we were considering the first number to be already sorted. So in this pseudocode, we could simply focus on the second element. So for I being the second element up to the last, then we are going to pick a temporary value, otherwise known as a key. So the temporary value that we could pick will be the A sub I. After picking the temporary value, we will simply compare it with the previous. So if we have another index, say our index is, say we have an index of j. J will be a previous value from the I, so I minus 1. And we're going to compare until we insert it in its correct place. So this will be a while loop. So while the termination condition will be, so the termination condition will be when the position j is no longer within the array. So that will be while j is still greater than 0, because we are referring to 1 up to n. So while j is greater than 0, and we're going to proceed. Now this is now for condition for the swap. We will continue to swap while j is greater than 0, and the temp is less than the current element. So the current element a sub I, or in this case we have a sub j, current element is, say, greater than temp, and we will continue the swapping of the elements. So this will be, the way we swap is by repeating the values. So this is an in place swap. So we repeat the values of j plus 1, say a sub j plus 1. We're going to assign the value of the previous a sub j, and continue the loop decrementing the j. And afterwards we have to end this one. So end while, and perform the final swap. So the swap will be a sub j plus 1 which will be assigned with the key variable, the temporary, when we find that this is already the rightful place of our current key or temporary variable, and we have to end for. So many lines? So you have 2, 3, 4, 5, 6, 7, 8, 9. So with just 9 lines, we came up with the insert sort algorithm. Although this, a better way of visualizing this is highly recommended, will be from Algorithmics, the insert sort with Romanian folknets. You can just go to their channel. Then we have our solved problem like this one. So given the following pseudocode, determine the type of sorting algorithm by filling its name, then fill in the blanks at each times columns, which is the number of times each statement is executed. So this is based on an example from our friends, which is Introduction to Algorithms by Corman et al. And I believe this can be found on page 18. So here's an example of bubble sort. So basically 5 is the first element that is sorted, and the current key here is 2. Then the next key is 4, next key is 5 or is 6, 4, and then after 4 the key is 6, after that 1 and 3. After that the elements will already be sorted. And the example or the problem for counting of the operations is or can be found here. So if the for loop will cost C1, then it was repeated n times, and within the loop, since the for loop, the outside loop, is repeating it n times, the actual execution is n minus 1 times, as we have discussed this during the lecture, that the extra 1 comparison is utilized by the for loop before it exits. So that's the cause of the extra comparison, extra operation. And that is the same case in the while loop. If t sub j is the number of operations for j before it exits the while loop, then within the while loop it is minus 1. Again, the extra 1 is caused when the while loop exits. So that is the final comparison before exiting or before termination of the loop itself. So that's it. The answers for this problems we have, this is referring to an insert sort. And the cost here is n minus 1, n minus 1, n minus 1. And this is just a summation of from j to 2, 2 to n, t sub j minus 1. Summation of j2 to n, t sub j minus 1 quantity. And finally the 8 will be n minus 1. And that's it. If we could implement this, it will look like this in C. So insert sort, we are accepting an input array and its length. Then we initialized a temporary or the key and indices I and j. So for I equals 1 up to its length, we are going to, so remember that I is the second element, so this is 2 to n. We're going to get the temporary variable for the insert sort and get the previous index of previous element and simply swap. So this, the whole thing here, this highlighted codes, this is basically for swapping, and we are going to insert the particular key or the temp variable to its rightful place within the sorted set. And for that, we need to swap if the current input or the current element that it's comparing with is greater than the value of the key, until of course we reach the limit where we need to terminate if we exceeded the first element or first index. And let's try to run this. I verified this with a particular set, say 5, 4. This is just numbers 1 to 10. We jumbled it a bit, so we are expecting a sorted element numbers 1 up to 10. So let's run this one. Okay, so we get the sorted array, which is 1 up to 10, and the pseudocode works, or the actual insert algorithm is a classical algorithm anyway. It's expected to work.